In this video, we will try to understand what exactly is WCF REST service. Now, in order to understand WCF REST service, the first thing is we need to understand what exactly is REST. So once we understand the fundamental of REST, then we will see what exactly is WCF REST service, and then we'll see a small sample of how to implement REST using WCF services. So let's first start with the full form, the most easiest thing. REST stands for Representational State Transfer. If we try to simplify REST further, we can say REST is nothing but using the current features of the web in a simple and effective way. Now, some of the amazing features of the web are: first, the 40 years old, matured and widely accepted HTTP protocol. That's the first thing which REST actually takes from the 40 years old web. Second, this HTTP protocol has standard unified methods like post, get, put and delete. Third, HTTP protocol is stateless. Fourth, the URI, that is a uniform resource identifier by which you can go and locate any resource on the web. So what REST does is it takes these four things from the 40 years old web and applies certain principles on them, and that's what is called as REST. So let's define REST in official words. REST is nothing but it is an architectural style. Please note, I'm just stressing this word. It's an architectural style built on certain principles using the current HTTP web fundamentals. Now let's spend some time here talking about this word architectural style, because I think it needs more clarification. Now there are three things which are confusing. One is architectural style, the other one is architectural patterns, and the last one is design patterns. Architectural style means it's a concept, it's a theory. Now how you take this theory and implement it is all up to you. For example, when we say layered architecture, somebody can take that layered architecture and use web services, use a class or use components, whatever it is. It's all up to him. How does he take a layered service and builds his implementation. So like example, 3-tier is the architectural style, okay, or service oriented architecture is an architectural style, REST is an architectural style. So these are concepts, and how you take this concept and implement is all up to you. Architectural patterns means they describe solution at the subsystem level or at the module level. So when we say that, okay, this is architectural pattern, in other words, we talk about components, we talk about subsystems and how they interact with each other. For example, model view controller, I think, is an architectural pattern which talks about how the view interacts with model and how the model interacts with controller, etc. Okay. Design patterns is solution at the code level. In other words, it talks about classes, it talks about functions, it talks about how actually the logic flows. So really, depending on what kind of depth you are talking about, these three things they lie in their own category. So REST is an architectural style. In other words, it's a concept, and this concept, how you implement it, is all up to you. Now let me add one more point here regarding the architecture style. Architecture style can also be implemented outside the software world. For example, when we talk about REST, right, we can take REST and implement it for a postal service if you wish. So when we talk about architectural style, it's really very, very generic. It also applies outside the software world. But currently, we are going to talk about REST web services. In other words, we are going to talk about REST in terms of software world only. Now there are 5 basic fundamentals of HTTP web, which are leveraged to create REST services. So let's go through each of these fundamentals, one by one. The first important fundamental in REST is everything is a resource. Now when we talk about internet, it is all about getting data. Now this data can be in a format of a web page, it can be an image, it can be a video, file, etc, etc. It can also be a dynamic output, like get some customer data who are newly subscribed or whatever it is. So the first important point in REST is start thinking in terms of resources, rather than physical files or SQL server data or whatever it is. Okay. So for example, below are some example of how a resource would look like. If I want an image resource, then it will be www.questmon.com/image.logo.gif. So this is an image resource. If it's a dynamically pulled resource, then it can be www.questmon.com/customer1001. If it's a video resource, it can be something else. If it's a static resource, it can be something else. But whatever it is, at the end of the day, in REST, everything is a resource, or whatever data you want from the net is a resource, when you look from the REST point of view. So that's the first important fundamental. The second principle of REST says that every resource is identified by a unique identifier. Now if you look at the old web, it identifies all resources by a URL. For example, let's say that you want to display customer with their orders. Probably you will use www.questpon.com/display customer and order.aspx. Now in REST, we add one more constraint to the current URI, saying that every URI should uniquely represent every resource data. In other words, if I want to get customer details of Shiv, then I will say www.questpon.com/customer/Shiv. If you want to get customer details of Raju, then I will append Raju at the end. If I want to get orders from Shiv, what kind of orders Shiv has placed, then I will say www.questpon.com/customer/Shiv/orders. So rather than pointing towards a generic page like this, in REST, we actually point to a unique identifier by which we can go and identify that data. So this is the second principle which we need to remember when we implement REST. The third principle of REST says use simple and uniform interfaces. Now remember that simplification is a way to success, and that's what exactly is the goal of uniform interfaces here. Now when external clients are interacting with your service, right, they expect simplified interfaces. For instance, let's say that you have customer and orders data which you have exposed on the web, and these are some of the function names by which external clients can communicate to your application. So for example, if they want to add a customer, they can go and call the add customer function. If they want to go and add orders, they can use insert orders. If they want to go and select a customer, they can use select customer. Now if you closely watch, right, the above method names looks inconsistent and difficult to remember, right? Now that's what REST says. REST says that keep your interfaces uniform and simple, and this can be achieved by using uniform methods of HTTP protocol and combining the name with your resource operations. So if you look at the HTTP protocol, it has a lot of common methods for creating, updating and deleting a resource. Now as we said previously that everything is a resource, right? And on the web, what you do is that you primarily do 4 operations on the resource. First is you would like to get a resource. Second is you would like to probably go and create or update a resource. Third is you would like to go and delete a resource. The last one is probably you would like to go and post some information at the resource. So if you look at HTTP web, which has been matured for 40 years, these 4 methods in HTTP web allows us to do these operations. So for example, the HTTP get gets a resource, the HTTP put actually creates and updates a resource, the HTTP delete deletes a resource, HTTP post actually submits a data to the resource. So if you can take these 40 years old methods which are now so famous and combine it with your resource, then your interfaces can be made uniform. So now if you combine the standard HTTP methods with your resource names, you can have uniform interfaces. For example, here you can see we have an add customer function. So what I've done is I have exposed a URL outside saying customer/Shiv, and if anybody calls a put on this URL, he'll actually go and add Shiv to the customers. In the same way, if I want to get some customer data, I can say customer/Shiv and do a HTTP get on that. So by combining the HTTP methods with the URL names, I can have more unified interfaces. So in other words, uniform interfaces is nothing but basically combination of your old HTTP protocol methods, that is post, get, put, delete, with your resource names. And by doing this, what you achieve is simplified communication. So this is the third important principle of REST. Keep your interfaces simple. The fourth principle for REST is all communications are done via representations. So in other words, you have a client and you have a server, and inside the server there are resources. So whenever client sends any data to the server and server then sends a response of the resource, everything is done via representations. So any kind of request and response which goes from the client to the server and back again are nothing but representations. For example, let's say that you want to create a new customer record. So what you can do is you can send some kind of a representation as shown on the video above, and probably you can send this representation by using HTTP put. Now once the resource is created, probably you would get a representation something like this. Now this representation is a response which has come back from the server saying that yes, the customer quest point has been successfully created, and if you wish, you can go and use the next URL here which is defined and create orders if you want for the quest point customer. So now the above representation, it was in XML format. If you want, you can also send representations using other formats like JSON. So for example, if you want to go and create a new customer record using JSON, then probably you would send something like this. And probably for this what you call request representation, probably you will get a response representation which can be in XML format or it can be in a JSON format. So at the end of the day, all request and response which takes place between client and servers are called as representation. So this is the fourth principle of REST, that everything is a representation which is sent via the request and whatever you get via the response. And the fifth principle is be stateless. Every request should be an independent request so that we can scale up using load balancers, etc. Independent request means with the data you also send the state of the request so that the server can carry forward the same for the next level if he wishes. For instance, let's say here's a simple representation we have. Now this representation actually sends in a user ID and a password to a system so that it can be validated. Now if the user ID and password is successfully validated, probably you will get a representation something like this, saying that that the login was successful, and that's a response representation you have got back. Now let's say you want to go and search customer. So now when you send a representation, now with that representation you will also say that currently you are logged in successfully. So in other words, you are logged in successfully, and do not again ask me for a user ID and password. So in other words, probably you will set some kind of flag like here saying that I was successfully logged in, don't again ask me for a user ID and password. So in other words, every request is independent and the server does not need to remember what you did in your previous request. So the fifth important principle of REST is be stateless. So finally summarizing, REST is an architectural style which uses the old 40 years HTTP web, and it applies 5 principles on the top of it. First one is think in terms of resources. There is nothing called as database data or image data, just everything is a resource. Every resource, whichever resource you want to access, is accessed by a unique identifier. Third is keep your interfaces simple and uniform by using the HTTP methods like get, post, delete, etc. Fourth is whenever you send request and response, you are actually sending representations and you get representations. And the last one is be stateless as far as possible. Now the next question which comes to our mind is, okay, now these are the 5 principles of REST. So how do we implement these principles in WCF services and create WCF REST services? Now whatever video you have seen, right, is just a glimpse of what we have done. So in case you are interested in our video package, you can go to our site, that is www.correspond.com. You can call on this number and you can ask the complete DVD package what we have. So in this DVD package what we have done is basically we have covered almost everything what a .NET developer wants. So right from basics of ASP.NET, object-oriented programming, SQL Server, to new technologies like WCF, Silverlight, Link, Azure, Entity Framework. We also have UML, architecture, estimation, project management. There is a complete invoicing project end-to-end which is covered, so that you can get a better feel of how to actually create projects in a systematic manner. We have covered server products, both for SharePoint 2007 as well as for 2010. We have a lot of best practices video on SQL Server, etc. So this complete package, you can get from www.correspond.com if you're interested, and you can call on this number and you can ask for the rates. It's a very decent rate what we have. In the same way, as compared to the videos, we also have one more product with us, that is our interview question books. So we have different kinds of interview question books, right from .NET interview questions to SQL Server interview questions, SharePoint interview questions, BizTalk interview questions, etc. So in case you are interested in the books part, you can call on these numbers as per your location. So you can see these numbers on the board at this moment. So I hope that you keep enjoying the videos, you keep seeing our site, and I hope that you gain more knowledge. Thank you very much.